Hey everybody, what's happening? Mewbot's already in the chat. Let me reset Mewbot. How is everyone doing and what questions are there? If you're in the chat right now, 201-320, say hey and feel free to ask questions. I went and got more coffee in the dog tour mug. Trust me, I'm a dog tour. He's a doggy and he's a doctor. Look at that right there. So cute. And he's got coffee. I mean, come on. What's better than that? So if you have questions right now, let me know. Let me know what your questions are. Feel free to ask them in the chat. 201-320, calling out to you right here. What questions do you have? Let me go through, see what questions there are. William says, can you open up the next assignment so we can see what the workload will look like for the next few weeks? I don't have it completed yet. I was going to finish it later today. Let me go see here. Let me see if I can go get it. You know what, William? Let's do that. Let's start talking about the next assignment. So keep chatting to me, William, right here while I go get some assignments going right here, and we can look at the next assignment. There is an activity tomorrow, and so my plan was to have the assignment posted later tonight, but I can start looking at that right now. It will be over the material we're currently covering, so let me go get that. Great question, William. Thank you so much. Let me go get that assignment. All the assignments. And I hope to get more out on the weekend to kind of have a head start for everybody on what we're covering. Oh, fun, right? I'm going and getting the assignment right now. And I might be able to get it posted. Like, we could work on that right here, like working on getting the next assignment posted. So let me go get everything. Okay. And getting the assignment ready. Yeah. You know what I think? I think we could go ahead and get this posted right here, William. I think I'm looking through everything. Typo. Fixing typos right now. I think everything's good right here. I think this is good. Okay. Let's take a look here in a second. It's a lot of bookwork. So we could take a look at it. You know what? I might be able to post it. Let me go ahead and save this. And then we'll get to see all this here in a second. Okay, let me go and start posting it. So 2 seconds. Let me see what people are saying in the chat. William says, yay! Will we have assignments and take-homes at the same time? No, my goal is that you will not have something due on the same day as the take-home. The take-home will probably be due... I might make it due... maybe Thursday? I don't want to put two things due on the same night. Since it's summer, there's about a daily thing. There's about a thing you should be doing each day. So Trace says, for I in... is the number one as simple as that? That looks to be correct right there, Trace. So, because it seems pretty easy. This Thursday... oh, no, not this Thursday. You should have put an exclamation mark next to that question mark right there. Not this Thursday. Not this Thursday. Not this Thursday. This is... okay. To... reach out to... okay. I'm making updates so we can look at the next assignment right here. I'm getting ready to get posted. There we go. Do not send work to other students. Okay. Let me put rubric forthcoming. I don't have a rubric. This was my like work for later tonight. Work. Sometimes they make this so hard to like figure out where the buttons are at. We're just chilling out right now. If you have questions, let me know. Howdy, Adam. Good to see you here, Adam. I'm watching the chat through Mewbot's eyes. So in Discord, can we have that variable question on the test? Of course. I definitely think I'll be adding that to the test right here. So that should appear on everyone's test. I might just make it a static question so it appears, and then I'll feel really sad. Just feel really sad if people get it wrong. Just started my SMC 309 class. What are you learning in SMC 309? What is going on in SMC 309? I don't know that class pretty well. So assignment, I got to upload the key for the last one too. So I should make it so the key's autocomplete. Okay, that's got it right there. Online, file uploads, unlimited attempts, due date. Let's put the next assignment out here. We're doing forecast currently. Yes, forecasting is super, super important. Forecasting, and that's what we'll cover in time series. So great job right there. Excellent work. We'll be covering that in time series, June 10th. 1 sec. Okay, good. Adam, so good to see you. Things like regression, exponential smoothing, 3-period moving average. Yep. You can just change the period of moving averages to look at like another forecast right there, like a 5 or 7 period, like a weekly moving average, all that good stuff. I think we've done it now. I had a lot of this ready to go, William, and I think we've done it. Let me take one last look at this. Okay, looking pretty good. I think we're good. Do you want to look at the next assignment here, William? Because you should see on your canvas, save and publish. The next assignment is now posted, due Thursday. We could go right here and take a look at that next assignment. Go right here, exactly, yep. It's a lot of just practicing the tools and techniques. What we teach in this class is widely used. So the next assignment should be out there, should be published. We're going to do an activity tomorrow. Don't forget that. So the end of class, last 20 minutes or so is going to be activity over association part 1. Let's do it. Okay, let's hop into this. Let me go get the homework packet because this one's going to utilize the homework packet. So let's show where that's at. I'll go grab it. Okay. Let's hop over here to the main screen. And I should be. I went and got some Pfizer yesterday. A little sore arm, but other than that, doing all right. Shockingly, don't usually get sore from those. They put something in my muscle. Maybe it'll make me nice, big, and strong. You never know. But I really hope to be. So I might plan out a ticket to fly in at the start of the semester to say hey to my students. And I'll be using my streaming PC, and we got to get that going. I've got work on the grant to do. You're still here in Knoxville. That's awesome. Like, I want to hold an event where we go to what is it called? I'm forgetting the name of the downtown place. The farms. Cruise Farms. I want to hold an event with their where I give them like $100 and then they maybe do half price ice cream for like 50 people. That'd be really nice. Probably they'd be like $100 half price item for ice cream for 50 people. Ha, not happening. Like, come on. They're like, we're busy enough as it is. We're busy enough as it is. Let's over to the main screen. I think that'd be a really cool Stats 1 event. Just be like, come out, get some ice cream, chill out. Chill out with Stats 101. What is this nonsense? Cruise Farms? You never had Cruise Farms, William? What? You never had Cruise Farms? Let's go right here. We're going to be using the homework package. So could you help me with number 5? I'm stuck on this one. I keep getting null with my vector. Yes, Trace. Are you on Discord, Trace? I see I've got 2 messages on Discord right now. I tried to stay updated on it. Send me your code on Discord if you can. I'll take a look. I'm trying to think what number 5 is. We'll take a look at the start of this right here. Let's go over to the homework packet. And we'll take a look at the first few questions right here. And it's just showing us right here some stuff with the analysis. And we'll take a look at this one. Yep, this one I'm currently teaching right now. That's what we're doing right here. Adam, do you have any advice for the students? Do you have any advice for them currently? You're currently in here with some 320 students. What advice would you give them? Give them all your advice you can. How can they be successful? And a lot of them are doing, so many of them are doing great. I say just start early, ask questions, come to class, just try to practice. And that's what we do. I think a lot of it comes down to just practice. So we're going to go right here. We're going to take a look at the first question, exercise 1, 210. I don't have any access to the files page on. So it shouldn't be in the files page. It should be under the tabs or the modules. Go to the modules section. I think this will be as active as you can. Ask questions, send off service, do the Kahoot reviews. Bingo. And we'll have a Kahoot before the test. So we'll have a Kahoot with prizes. So definitely do the Kahoots and everything. Be active. Adam just knows. We got some 20 points right there for Adam and everyone else. You should have access to this right here. William, is this making sense right here? The homework packet. I think does it block you from then looking at it? Because I think you should be able to then, I think you should be able to click this. And then when you click this, it'll then take you to that page. Is that working properly or not working properly? Awesome. Glad to hear that. Let's go here to exercise 1. Oh, look what we got right here. I'm just going to copy paste this. And this is what we were talking about today. So we can take all of this right here. Just you can go through this, and we've got all the different stuff. Just expanding a little bit right here. So we're looking at what is the x variable and what is the y variable. Remember that x explains why something is happening. Okay, so with the first one right here, the color of the background and the time spent on a website. So we could change this around if we want. You know what we can do? We can go to Markdown Editor. This is something new, Adam. You can actually go to Markdown Editor in this, and it's taking a moment here. It's like loading it up in the background. It actually runs a little bit slower, but once it loads up, there we go. I was almost perfect on that. You can actually see what everything looks like in the Markdown Editor. So if you want to do this right here, you can actually bold this, and we can go right here and start just doing our own ABC. So I just went into this, and I'm editing it. I took everything out of the book right there, and I'm just making my own nice and easier way to look at this. Once again, I'm in the Markdown Editor right here. Just makes life a little bit easier. One of the new features inside of mobile device. Bye. I don't want that button anymore there. So there's all the questions right here. And so now we've got it in here. We can bold this. Look, it's just got normal buttons like Microsoft Word. I mean, who would have thought? And this is one of the new features, which is so cool. I think we worked with the Markdown Editor. Yeah, so we use the Markdown Editor with the equations. And then this is like a new thing right here. This button, I'm pretty sure it's new. Maybe it's not. Maybe I just never clicked on it. But you can do the equations. I think you can just insert an equation now. William's on the right track right there. Yep. So you could probably insert inline mathematics. And you see it does that right there. So you can do like 2 plus 2. And it shows it to you right there in that moment. And versus the display mathematics, which I think the display mathematics is what will actually display when we do it. So the display mathematics is a little bit different than the inline mathematics. But it's really nice. It actually shows you it. I don't know quite the difference between the inline and the display. Like, I think display will knit in the other one. Yep, you remember the double dollar signs. Yep. And then, yeah, so wow. And then if you do like \mu, really? There we go. Oh, there we go, \mu right there. Anyways, I think William is just destroying this question right here. Let's see what William's answers are, because William is just crushing it out of the park right here. Color of a background, we're going to put right here X, and time spent on a website, I'm going to put Y right here. You might try to help me out. Let's see what here. Cashiers and time spent. I'm going to go ahead and reverse this. And this would help me out immensely if you have them all in the same order. If I misgrade your stuff, please tell me. William is just crushing it right here with the number of cashiers would explain how long you have to wait when you go to the line at the grocery store. The color of a background might explain why somebody has time spent on a website. So the probability, careful, William, on the C. On C, we're asking the price of an item and the probability of purchasing. So you can kind of reverse it, but think about which of these they might be more likely to adjust, and which of these they're trying to... Are they trying to explain how much their items cost, or are they trying to... That's William's new trash word right there. Do you think they're trying to explain how much the items cost, or they're trying to... Are they trying to understand... Yeah, are they trying to understand the price of an item, or are they trying to understand, which I shouldn't say explain, because what is explaining what? Because right now you're saying the probability of purchasing explains why something is a certain price, which kind of makes sense. I do agree. Maybe more from the business aspect, we might say, I sent you my RMD through Discord. Awesome, Trace. Let me go look at that here in a half second. I'd reverse those. I might not put the rest of these answers. But when you think about the company aspect, they might say, we want to understand why people purchase a certain item. So that's kind of the answer for that one. Like, why do people purchase a certain item? And then what can we manipulate? And so when you think about this, X is usually the one we manipulate, which gets back into the independent variable idea. So in You're right. And you might say, well, can we manipulate the weather? Well, no, but we might watch the weather and understand how the weather explains demand. So you are, in this instance, we can't actually manipulate the weather. Or maybe we can, I don't know. We seed the clouds, sure. Then we're like, yes, we made it rain and we got less sales. I don't know how sales work. Whether people click on an ad and the mobile device they're using. So what do you think is of interest to the company? Do you think the company cares about what mobile device people are using? You might say, what is this, a cell phone carrier? Then they might care about your mobile device, but probably this is like some internet marketing thing like YouTube ads. So that one I think should be self-explanatory too. Is this making sense here, William? Like, so the biggest thing, I think William's seeing it. I mean, we just did. Oh, I need to change the points on this. I'm going to update the points. Don't look at the points. I'll update the points probably later tonight and put it into the rubric. Please note that all the rubrics have the points associated. Luckily, I was very nice in how I graded the first one. It said like 2 points, 1 point, but not that I was drastically changing it, but the points were out of like 20, I think. So I could have taken off way more points, but the way I took off the points was relative to 100. So if you go back here to the assignments, you'll see for assignment two right here, for loops, it very specifically outlines how the points are taken off. So makes it nice and easy for grading right here as I just go through and assign your points the following way. I tried to be as specific as possible. It's just really tough because there's about a billion ways to make mistakes. So you might see an additional note if something, I have points taken off, but it should be very, very clear. And I'm going to reallocate a little bit of the points here and create the rubric. So sorry, there'll be just a little update to the assignment where it's very clear on how the points are associated. Look for the weighting to be about the same because I think the point total might be a little bit different because I haven't updated that yet. But does that make sense on how all the grading is done, William? And everything should be pretty clear on what the questions are and where the mistakes are probably going to be at. It's just I should add an additional note like, if you could always do a mistake I don't have marked right here, so check for notes that might escape my rubric on how I have to grade you. Like, because I don't know. Like, if you leave it blank, that's really easy. No marks, left blank. No marks, left blank. This is how I grade it when I go through and click it. So all this good stuff right here. Let's go ahead and look at Trace's question. I'm going to hop back to the main screen. If you're here, 201-320, feel free to ask questions. I'm thinking of making a Games Done Quick thing where I'm in the corner and I've got like questions upcoming, especially for the semester, because I'm teaching this semester I'm going to teach 4 different classes. It's going to be a crazy semester, I'll tell you that much. Let's go ahead and look at Trace's question right here. Trace is Treblu. Let's go ahead and take a look. I might not show a Trace. I might explain this to you right here. And then, William, feel free to ask more questions. Question number 5, you say there's an error. Let's take a look. Okay. So let me see here. You're getting the NAs. I see what you're saying. Oh, I think I see what it is. Oh wait, you don't have your subset function in here. I see a few things. I think I fixed it. Let me see if this worked. Okay, it's not switching it. Looks like you combined 2 things I did yesterday. Because I did a lot of different ways of doing it. Levels. This should be day. Okay, I got it. Let me see right here. Let me go back in time. Okay, Trey. Let me take your code. I'm going to close out of your RMD. Let me open up a new script. Go over here. Okay, let's take a look. Okay. And, okay, good. Let's go ahead and take a look at this right here. We did it yesterday, so. I emailed you about this, but was the skeleton you used for question 2 yesterday correct? I think so. I was replying to some emails while drinking the coffee. I've been exceptional at making unusual mistakes. The skeleton I used for number 2 yesterday. Where's number 2 at? 2 seconds. Let me find that. What skeleton did I use for number 2? It should be. It should be. Was there an error in it? I'm looking at it right now. Maybe I made an error. No, maybe I didn't. I don't know. Did I not assign... Oh, Brandon, you might have pointed something out. Do you give it the UT basketball? Used 5 in the skeleton, but shouldn't it be I plus 1 plus I? Let's take a look at that next, Brandon. Great question right there. We'll take a look at that next. Let's review that because maybe I made a mistake. I make mistakes every once in a while. You never know. You never know. You got me wondering right now if I made a mistake on that, so I'll need to check that out. So here's the current code right here, Trace. I went through and took a look at it. And what is missing from your for loop right here? So what is currently missing from the for loop? For 2C, maybe that sounds right. Looks like you're looking at some marginal distributions. That looks right there, William. That looks like marginal distributions. Maybe. I don't know the answer off the top of my head, but that looks like marginal distributions to me. Good job right there. So what is missing inside of your for loop? Because right now you're going through and you're storing into, you're using subset. So you're using the same subset. That's a key right there. Good job, William. So you're using the same subset every time, Trace. Does that make sense? So what needs to be done right here? Because every time your for loop runs, it's going to use the same subset. So what we want to do right here is we want to take and we want to put the subset inside of here. So the subset should be inside of here. Like the subset should be part of this, that when the for loop runs, it creates a subset of a certain day. And with the subset being for a certain day, then we would need to go and we'd say, okay, we're going to go inside of here and day is going to go through the levels of tips $weekday. Does that make sense? And then it's going to go here and subset from the tips data set, the variable weekday, and here's where the change needs to be made. What right now is our placeholder? What is our placeholder and what should this become right here? Because it's just going to become the placeholder that changes. And this should fix everything right here. And so you can tell me if this fixes your code. So do you see? So we need our for loop to make the subset, and then it'll store into the vector, which you have right there, the vector it's storing into. So what will that become? And there was 2 ways I did it yesterday. That's one of the ways. You got it, Trace. So is this making sense here, Trace? We're just kind of debugging the code. I'm going to kind of leave it at this right here. Because I always want people to think through this. Like, we've got a lot of answers floating around, or a lot of ways. No, it should just be days. Because when your for loop runs right here, and you can see it over here because I ran your for loop, just investigating to make sure everything works. Days will take on, so you should see days here, or day rather. Day takes on the value Thursday when it runs, because I was running your for loop to make sure it worked. So literally, if this becomes day, it's going to look for day. Does that make sense? You won't use position day. That might actually work. It'd work, but I don't know. It might. I don't know if that'll work. Yeah, it's not liking that. I was like, I don't think that'll work. Oh, what's it mad about now? I read just a moment ago. 2 seconds. Yeah, that's working. This is what it's mad about. Oh, I know what it is. Yep, there's one more change to make too. Okay, so, and maybe it would work if you did this right here, but when you do the mean, do you want to do the mean of weekday? So if you notice, I was running the lines in the for loop to see if they ran. Do you want to do the mean of weekday? Because do you want to do the mean of weekday? Do you want to do the mean of weekday? And I wouldn't use this like this. I would change this to day right here. Do you want to do the mean of weekday? Do you want to do the mean of weekday? And I highly suggest everyone watch yesterday's video. We're debugging a thing right here. So you don't want to do this all at once. We did this yesterday step by step by step by step. If you're watching this right now, look at yesterday's video where we walked through the steps to do this. You don't want to just write this all out. You want to do it step by step by step. So do we want the mean of weekdays? No, we don't, because this is a factor vector, and I wish it would just print. That's a factor vector. What do you want the mean of? And this should fix your code now. What do you don't want the mean of weekday. You took a subset of a certain weekday, And now you want the mean from that subset of the variable what? Okay, that should do it. And will that run? It's mad about this. I think that's the problem right there. There we go. So that's got it right there. I didn't think the other way to run because it's going to position. Yeah. Does it make sense? Is your code running properly now? I don't want to like show it completely here. I want people to kind of go through here step by step and practice and write it and come across these errors just like you did, Trace. And then we solve it and we're like, got it. We've been talking about this for 5-10 minutes now, and hopefully it's making sense. Conditional distribution is the values of the row total, not the grand total. Yep, if you go across like a row right there, if you want to check some answers, we can do that here next. We've got Brandon's answer. We'll take a look at the question Brandon has. Great job, Trace. Put on a little 80s music. Great job, Trace. That's what I want to see. Like, I want people to work on it. You run into an error, you're just like, hey, what's going on with this code? We debug it, we fix it, you're good to go. And that's why you got to start early. Because if you start early, you hit an error, you just say, hey, it doesn't work. And I say, oh, you're taking the mean of weekday. And you say, oh. I miss being in the office hours with people and like them being like, oh my gosh, that's the best. I know it sounds crazy to be like, it's the best thing ever when someone's like, I can't believe I made that error. But that to me says they know what they're doing. It's just a small error. And there's like, try and take the mean of a factor. What happens? Let's hop over here to the assignment and let's take a look at it. Where's that assignment at? Here's that assignment. Let's find the skeleton in number 2. Here we go. Okay, so the skeleton is the code that repeats inside of a for loop. So identify the vector. Well, the vector is the numbers this goes through. I'll have to look at yesterday's video to make sure I did this properly. If you look at this, this goes from 4 to 10. It can also go from 5 to 11. And I feel like I must have made an error yesterday. Because I don't remember doing all the I's. I feel like I made an error. I'm going to like go watch yesterday's video on this. Oh, man. I'm going to have to like make the key 2 ways. So if we go right here, this is part of our skeleton. Skeleton is the code that repeats. But if we're going to bring this through the elements 4 through 10, well, then the first time this runs, I would be equal to 4. And I don't recall changing the 5. So I think that's where an error was. I'm pretty sure I made an error yesterday. So this needs to be, because I is currently 4, I plus 1. I'm pretty sure I made an error. No one caught the error. We're going to have to, because I made the error, I'll have to make sure the grading key reflects, and we let people make that error. So there's the skeleton, and the skeleton is going to go from, or we have I as the placeholder, 4 through 10, and object X not found. I didn't create the vector X. Vector X needs to be created. And we go right here. Is this what I did yesterday? And I think it says print the tail of it, right? Is that what people are getting? So Brandon, is this what you got? Is this the last 6 elements printed out? And we should see right here. I'm hoping I did this way yesterday. I don't recall changing this one right here. I might have left the 5 static, which would slightly shift the question, which is not good. Yeah, that's as I'm looking at this, so I'll have to just grade that as correct because I forgot yesterday. No, so Brandon, you know what, Brandon, you just got everyone 100 points. I'll just have to grade that as correct because I made an error. It happens. No, Brandon, thank you so much. Yeah, I was like, I don't recall changing that 5. The 5 does change, and it's always 1 higher than this. Just sometimes an error happens, and yeah. So I did not properly change this yesterday. I kept 5 static, which then, as this code repeats, looks about right. I could take a look at. Do you want to talk about that next, William? And thank you, Brandon, so much for pointing that out. Please, 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 when you notice an error, please tell, or even if it's afterwards. Like if you notice it during class, you notice it during office hours. If you notice it afterwards, be like, hey, Brown, I think you made an error. Yeah, so this is an error right here. It needs to be I plus 1 because I starts out at 4. Blake says, Brian, sometimes when I'm running code to stop the R, stop solving my code and reprinting it in the console. For example, 2 plus 2 comes out just as that instead of 4. How can I fix this? Can you send me a screenshot? Go ahead and just take a screenshot of where you see on your screen. Throw that. Are you on Discord? Throw it on Discord and I can take a look at it. For number 5, my code runs, but the output looks weird. Could you help? Yeah. Throw me your RMD on Discord. Or if you want me to take a look at your, as long as you're okay with me kind of tinkering with it on here, Blake, Ben, throw me your RMD on Discord. We'll hop here to Spice. Let's do this. So throw me those RMDs on Discord or email me them and tell me you emailed them. I'm take a look at one more message on Discord from somebody. Tread Blue messaged. Stat Nation says, question for the test. In terms of X and Y, which variable explains the other? X explains Y, Tony says. Great question. The new assignment is posted. And the first question goes over this. Awesome. I did D, but it's too many characters. But it's... Let's take a look at some more questions right here. Excellent work, everybody. Keep those questions coming. I'm going to look around to see what I have. Let's see right here. Let's see, Brandon says, I'm going to write error and reply to you. Oh, no. Thank you, Brandon, for pointing that out so much. Now I'll have to make sure that I grade it properly. We'll see right here. We got 2 messages coming in from Ben. Ben's got the code right here. It runs but looks weird. Thank you, Ben. Let's do a little debugging right here. Okay, Ben. And remember, just to check, you're okay with me displaying this right here? It's kind of the... Can you check my question 2? Yeah, let's do that next right here. We will check question 2 next on the new assignment. So, Ben, you're okay with me showing some code right here that you just sent me? All good. I'm going to hop onto the... As long as Ben gives the yes. Or you can say no. Either or. Let's make sure I was like... Awesome, Blake. We got yours next here. Let's take a look. I think Ben's going to be okay with this. As soon as Ben says, yep. Blake's cool with it. I should just put that as a disclaimer, like, code sent during class, or code sent, like, during office hours, you're okay with showing. I think Ben's okay with it. We'll just make sure. Well, we will confirm. I'll put on just a little more music here. Double checking with Ben. Everything all good, Ben? Show code? I can debug. Let me start debugging it while we find out. Awesome. Cool. Boom. Here we go. Let's take a look. Okay. So you've got your... this is kind of used as like a control panel outside of this. We don't need it right now, but it's no big deal. So it actually won't assign the value of I1 to start. What will I become the first time this loop runs? I will become, I think, Thursday. Darn graphic error. Friday. So it's because the margins are so small. It's mad about trying to send things over there. One of these days I'll figure out how to eliminate that. I would throw some mega points if someone figured out me how to do that. Awesome. And so it's going to become Friday. And I think this is it, because I did like 3 ways of solving it yesterday. I think this is the problem that people are running into. So literally the first time this runs, I is Friday. So what you have to think about right here is I is Friday. And you can check to see if this runs right here by putting I Friday out here and running this. And you have weekday equals... Okay, this is the subset. Good. Yeah, I didn't see all this. And so if this runs, we've just created a subset of Friday. So the reason this works is because this is currently Friday. Like, literally at the moment, this is currently Friday. That's what I is. So I is Friday. And then we have this. You're taking just a subset of this. Now, we need to remember that this combines the 2 ways I was doing it yesterday. I is currently Friday, which is the same thing as just putting right here Friday. And so let's just put that to I again, because I is Friday. And then it's going to take the mean of the subset of tip, and it's going to store it into average tip vector. The only thing we're missing right here is we need to create the average tip vector. And there we go. You're good to go. Does that make sense, Ben? The changes I made, just remember, this is one way of doing it right here. The other way because I did it a few ways yesterday. If you use 1, you could use this, but now you'd have to do the following. So now it needs to be this. That might work. I think this will work. That works. Okay. So this right here is going from 1 to the length of the levels vector of tips weekday. And the length of the levels vector of tips weekday is 4. Literally, this whole code I've written right here is literally the code 1 to 4. Yeah, exactly. Trace, feel free to put in the queue. We're doing Blake's question next. I think, William, did you have one too? We can go over Williams. We can do Blake's, Williams, Trace, and definitely keep asking those questions. I'm gonna try to create a GDQ background where I put like the questions above me and it looks like all video game background S, and I put R in another. I don't know. I have plans. I've got so many ideas. But all this is 1 to 4, and then right here we're taking the subsets. It's going to the first level right here. So since this is now 4 right now, it'll read Thursday. So this whole code right here is going to the 4th level because now the code goes 1 to 4. But does this make sense here, Ben? How this way of solving it goes through the values of 1 through 4, and then the way I had on the screen here a second ago, I went through the values Thursday, Friday, Saturday, Sunday. So right now it's going through the values 1 through 4. So when we go here, we're going to the first level of tips weekday, and that will evaluate to, it's actually the 4th level right now because the loop completed. But this is going to position in the levels vector. But if we change this such that I will take on the values right here of, it's tricky because you can change it so that I becomes just those values. And now I is literally as it runs Thursday, Friday, Saturday, Sunday, all those days. And so now I is taking on those values right there. So here's one way of doing it where I takes on the values Friday, Saturday, Sunday, Thursday. Then we go to weekday and we go to I. And then right here, I is taking on the values 1 through 4. So we go to the first position in the levels vector, which would be Friday. This still just returns Friday, but it does so by returning the first position of the levels vector for the tips weekday factor variable. Woo! That's a lot of language right there. Good stuff. Good practice. Just know what's going on right here where this goes through 1 through 4 and the other one goes through Friday, Saturday, Sunday, Thursday. Awesome stuff right there. And it was Blake's question next. We'll do Blake's question. And then William, which one do you want us to do, William? So William, we'll do Williams, then Trace's. William, which question do you want me to specifically talk about? Looks like you're crushing this assignment. Oh, we already played that one. You're welcome, Ben. Keep asking those questions, and thank you so much, Ben. Let's go look at Blake's question right here. Oh, you said it was fine to show on the... you replied to me on the Discord. Blake, oh, there it is right there. Here it is, office hours ABC. ABC. Let's do this. Hopping over here, and Blake's question was, let me look at Blake's question again. Give me a yay or nay. I don't know. I don't know the question. I don't know it off the top of my head, William. Do you want me to look at that one? I can look at that one next and talk about it. Look around line 36, okay. Okay. I don't know the question. Oh, I see it's not printing out. I see what you're saying. Okay. Let me look. I can fix this for you right here. Oh, I know what it's gonna be. Okay. Yeah, I don't want to put this one out there because this is one of the ones I want people to figure out. Okay, here we go, Blake. You ready, Blake? I'll kind of show it this way. You ready? Let me show parts of this. Okay. Let me show it as is, and then let me change this. We'll show this right here because this won't be the answer, but we'll make sure people kind of see what's going on. All right, you ready? I don't have them all memorized, William. Is that trash, William? Okay. So you have right here name, which is a blank vector. Name is a blank vector. So we don't need this just because we're not storing into anything. So let's just remove that off here. Name right now is a blank vector, which means this loop this loop won't run because name is stored in the global environment. Which one do you want to talk about, William? Do you want to talk about Q2E? I just don't have all the answers memorized off the top of my head. So part of this loop is to get the loop to run your name plus appended to it 1 to 5. So when this loop runs, what changes in the loop every time it runs, Blake? What changes in the loop? Like, what value will change? What value will change in the loop every time it runs? Like, what variable will change in this loop every time it runs right here? So what will change in this loop? I'm not, this isn't the direct answer to the question, but I think it'll allow you to shift yours to make the correct output. I will change, exactly. I will change. Does that make sense? And it'll go through each. Yep. So I is going to change. So you want I to go through the values 1 through 5, right? So what do we need to change here? I think it's when you look at a for loop, you got it, William. We'll do that one next. You got it. So what should the vector be that your loop is going to go through? And this, I think you'll get the right answer right here after this. Like, you'll change your code around a little bit because you'll be right there. What do you want your code to go through 1 through 5? Which this is one of those codes when we practice, we're like, oh, just make this vector. Oh, you're like, I see it. That's the vector of things it'll go through. So, great job right there, Blake. And that's not the answer directly, but I think, is your code working right now? Did you make some little changes to it? The 2 plus 2 and everything ran. I was running that down here. Oh, there's name. I was checking your code, making sure it works. As you can see, I got the code to work right here. I think you can get it also to work right there. I think you're right there. I think everything should be working. Does that make sense? So for those wondering, there are 2 arguments inside of the paste. The arguments are separated by commas. Your name is a string, which means it's in quotes, and that's kind of the answer to number 1. So some good debugging of number 1 right there. Good job, Blake, getting stuck right there, and then solving that question, getting it done. Great work right there, Blake. We're going to do William's question on Q2F. Let's hop back out of space. Sad chill music. Awesome, Blake. Next time, just whenever you get stuck, just let us know. Great work right there. Awesome job. Let's hop over to the next question. We got here Q2F. You are welcome, Blake. Excellent work. Q2F. What is Q2F? I don't know. Q2F is from page 70. Let's look at page 70 right here. Page 71 I'm on. Here it is. Ooh, good stuff. This is right where we got to today. Awesome work right here. Let's take a look at the question. Calculate the... Oh, that we're not doing that one. So, some good stuff from today. That was from today. The value of the discrepancy between all expected and observed counts turns out to be 1.017. Below is the simulated sampling distribution of 5,000 discrepancies. Samples with no association means they're by random chance via the permutation procedure. This is exactly where we got to today. Is the association between it statistically significant? Why or why not? And the answer is to do the following. So when we do a p-value, which we're going to start next class with this, when we do a p-value, kind of. No, that's exactly, that's correct. I'm going to go into a little more detail. William, 20 points right there. You're exactly right, William. Like, I'm going to go into a little more detail. And this is what we saw at the very end of class. Like, literally, it's the slide we ended on. So this question right here is the exact thing we're doing. So we have to plot our discrepancy. Our discrepancy is going to be right here. Oh my God. And William is right that this is, I would say the discrepancy is small. Like, not the differences are discrepancies. This discrepancy value of 1.017 is very small. And if it's small, that means the what is very large right here. What is Brian shading by shading this area? This area I'm shading on the screen is actually the what, which we talked about a very small one today. Here was this from today, and you look, it's still over here. This over here is the what when we do this. That one's about equal to 0. Mine's probably equal to about, I don't know, 80%. Something like this. And what am I showing? So this is a very large p-value. Great job. That's the p-value. And we'll put in about equals because I don't know what it's perfectly equal to, but I mean, it's about 80%. Does that look bigger than 5%? Most definitely. Telling us that our results here are probably just due to what? Like the differences we observed, which is the discrepancy. The differences we observed right here are very small. And by random chance, we could get differences as large or larger than this. It's very probable. Meaning that when we look at the discrepancies, we'd see something where they're pretty close. And then over here on this example, if you looked at the discrepancies like this one here, you'd see something large. Small discrepancies are going to look like this, which are likely by random chance. Large discrepancy, which we have our observed result here, is unlikely by random chance, and i.e. the p-value, this one's estimated to be 0. But yeah, does that make more sense? William, excellent job right here. This is a great conceptual one. And to see how we would plot the discrepancy and how we would find the p-value, and then we would see a graphic probably where the differences are going to be small and look like they are likely by random chance, i.e. there's a high p-value. So is it statistically significant? Most definitely no. No, because the discrepancy value of d equals 1.017 is very small and our p-value is very large, which suggests differences are like... William, another 20 points. Amazing answer right there. I got nothing to change on that. Yes, William, excellent work. Yep. And that's exactly it right there. Small discrepancies lead to large p-values because they're likely by random chance. And a large discrepancy would lead to a small p-value because it's unlikely by random chance. What is a large discrepancy? Well, we'd have to plot it. Like if you look over here, like 10 would be very large on this graphic. Where if you look here, I guess 10's also very large. It's similar. Maybe that's the... Maybe there's... it's hard to tell. Maybe it's a chi-squared 2. Maybe that's a chi-squared 3. I don't know. They're based off the chi-squared. They're simulated chi-squared distributions. It wouldn't be a chi-squared 1. Chi-squared 2 maybe. That's a chi-squared 3. I don't know. I don't know these things. So, Mubot, tell us about that chi-squared. What's interesting, and I really mean this, is if you look at what we're simulating right here, I think Mubot knows chi-squared. What we're doing by doing the permutation procedures, we're actually doing classical statistics via simulations. And so Mubot should bring that up. And let me do the code. We looked a little bit at this code today. There's the chi-squared distribution. So let's go ahead and take a look at this code really quickly right here. Let's look at association between gender and handedness. Gender, handedness. Data equals survey 10. And then Trace, what was your question, Trace? I know Trace had a question next. Y tilde X comma data equals. And really? There we go. Oh. So there's that. And if you look at this distribution, this is chi-squared 2. We didn't even talk about degrees of freedom because we don't need to know that for ourselves right now. Let me up the permutations right here. Permutations to 10,000. Is it going to get mad? Am I sure I want to do that? Yep. And now we're going to see a chi-squared with 2 degrees of freedom with 10,000 permutations. And so there's the chi-squared with 2. And let's go to Mubot's suggestion for us and go to a chi-squared with 2 degrees of freedom. And what you'll notice right here, between this, the random simulated one, and let's do 100,000. Will that make it smoother? And then we'll look at Trace's question. So here's the one we're getting simulated, which looks to end off at about 10. And if you look here, this looks to end off at about 10-ish. And yeah, this is a simulated chi-squared by random chance. If you could go over subsets, I'm a bit confused on them. And yep, when to use them? Yep, let's do that next right here, subsetting. And we'll see if I can get my chi-squared simulated distribution with 100. And look at how peaked it is at 0 and towards 1. And you'll notice that same sort of shape right here. We're just going to see with 100,000 permutations. And this is why we don't do 100,000 permutations, because it's taking a while. If you notice right here, the differences are very small, very likely by random chance, with a very high p-value. So once again, you see small discrepancies, and that's the discrepancy value. And then look at that. Wow, I love the way that looks. Nice and smooth, just like this one. Goes almost to 10, and this one really has a drop-off at about 10 right here. There's a very low probability, especially when we look at above 10. Only 0.7% of values are above 10. So ours probably has some values above 10. It's just so small and hard to see because actually it plots to the highest value we got by random chance. And if we were to go way down right here and do this a lot quicker, you'd see it go to about, yeah. So now we might have had a value all the way up there, but yeah, there's some values up at 10. So anyways, let's do this right here. Let's do some subsets and let's go back and do this. Okay, subsetting. Let's do this. Okay, heading back over here to do the subsetting. No, wrong button. Okay, so let's take some subsets right here. With subsets, there's a lot of ways to subset. I'm going to increase font size. There's a lot of ways to subset. You can subset with a data frame. So I already have the data frame loaded in. Data frame is located inside of reg class. And when you subset, there are really two main things I always work with. The two main things I always work with in subset are the data frame I'm subsetting. And you could subset a vector also, but there's other ways to do vectors. I usually use subset on data frames. And then the next things are the conditions or condition you are subsetting on. So let's first start out right here and trace. I just want you to write the code in the chat for me to subset survey 10. And so the first thing is the argument is, what do you want to subset, which is the data frame. So go ahead and take and put in the chat right here, I'm going to subset survey 10 data frame. That just tells it, where am I going to subset it? So go ahead and try putting that in the chat right here. I figure we got this one. Like we know how to get to there. Like this is just what I'm subsetting. I'm just saying this is the object we're going to work all the subset commands on. And so that is the first step, is just saying, what do you want to create subsets from? Got to answer more questions. Got to keep going with those questions. I need to up the points. We'll do that here at the end of class. I got to reassign the points. Subset survey 10, boom. And now if you look at this, it's just going to print to the screen right here. And it's not subsetting on any conditions. So it's really not doing much of anything. It's just subsetting survey 10, not really doing anything. So now let's say we only want people. So we're going to switch arguments here and put a comma. Now, some people don't hit enter, but I highly suggest hitting enter, which will keep you inside of the function, but it just allows you to make like a new line and make things easier to read. So we're on a new line, we're on a new argument, just makes it easier to read. And now I want only people, and we're inside of here, I want only people who have a GPA of at least 3.0. So how could I get only people who have a GPA of at least 3.0? I want only people who have a GPA of at least 3.0. Only people who have a GPA of at least 3.0. And this is where we're doing the conditions. Like this is the main part of a subset right here, is where we're doing the conditions. We're saying, okay, now we want only people who have a GPA of 3.0. How would I write that condition right here? How would I write, they must have a GPA? Close. And there's a few things right here. So that will find, and it might work. One thing is we don't need to put the dollar signs because we're actually inside of survey 10. So since we're inside of survey 10, we don't have to put the dollar signs. If you do that, it should still work. I believe we could store this before we start doing this to see what the size of it is. That's just going to store whatever we create into something. So we could go GPA, and we want to do greater than equal to 3.0. And if you look right here, that gives 467 observations. And we could do the following, and it gives 467 observations. So since you're inside of it, you don't have to do this, but you do get the autocomplete by doing this. So I personally, there's another trick you can do. You can attach, which lets you have access to the vectors. So now watch this. GPA, and it's 3 letters, so it's not auto-completing. But attach attaches the vectors to the global environment. So now I want to say, I also want, and they're right-handed. So I'm going to say, and. I'm going to hit a new line. It's sub-indenting here to say I'm still within this argument. The sub-indent right here means you are still within your second argument. So we're sub-indenting, like we're within this right here. So here was the first argument, the second argument. We're still within the second argument. I want them to have a handedness that is right-handed. Now be careful, because right-handed is like, it's a factor, it's a level, but it's seen as a character vector. So when we go to handedness, we want right-handed, and you can see how it looks over here. You can see ambidextrous, but you can see how we should be writing it. That was one thing that got me often. And we want to do a logical check. So we want people who are right-handed right here. How would I get, and we want people who are right-handed? So handedness is the name of the variable. And how would we get and people who are right-handed? How would we do that right here? So we're saying we want to take survey 10. We want people who have at least a 3.0, which is their GPA is greater than or equal to 3.0. And we want people who are right-handed. So how do we do and we want people who are right-handed? Right-handedness is the variable. So you're going to have to logically check to see if they're right-handed. And I'll show you more about this. Because we'll be doing some logicals right here. Yep. And that would be, what you might want to check while doing this is you might want to check handedness. What's interesting is I can run handedness right here, and so you can kind of see that right there. It is inside of survey 10 also. It's the attach. Oh. The attach lets me run just handedness. When you run attach, it's iffy because you better watch. You're attaching things to your global environment. But it would be right. And so we would go here to handedness. It's going to autocomplete because it's currently attached to the global environment. And there's that right there. But watch this. We're saying, does somebody have a handedness level equal to right? We could say, or, I'm going to put this inside of a parentheses, or they have a handedness level equal to left. And it should be capital left right there. I'm going to put this inside of its own parentheses so it does its own thing. And this is now going to get right or left-handed people. You could also do not ambidextrous. So you see here we have the level ambidextrous. Interpreting the code, given a number 2 on the homework. Yeah, Blake, sure, yeah. Let's take a look at that next. You got it. So here's another way of getting the exact same thing accomplished we just did a second ago. Instead of saying right or left-handed, you notice this still says 450. We could say they're not ambidextrous. You notice we still get 450. These are the people who have at least a 3.0 and they're not ambidextrous. But there's one last way to do it, which can really help in some instances. And these are all the same way of achieving the same goal. %IN % means somebody's level of handedness is contained in the following. So this will get people who have a level of handedness that is either right or left-handed because their level of handedness is contained in the following. And watch as this remains 450. So you just saw a few different ways of doing it right here. We'll take a look at Blake's and then William's question next. Is this making sense right here, Blake, how I've achieved the goal a few different ways by saying, find me people who are not ambidextrous, find me people who have their handedness contained in the vector right or left-handed, find me people who are right or left-handed, like someone is right or left-handed. And I put parentheses around this just so this would evaluate all on its own. Like I want a condition to be and they are right or left-handed. So I want this to evaluate as its own. It's an interesting question. We'll do it next. You got it, William, after Blake's question. But does this make sense right here, William, how I'm writing this condition? And I'm doing that right there. I'm trying to think if there's anything else I want to mention. I might mention the select. So you have to watch out. When you hit comma, you're starting a new argument. And that's why I like doing the sub-indents right here. And I do enter after my commas. Select is just an argument which it's going to have settings to it. So we're using the equals. And we could select only somebody's. We have to concatenate this because we're grabbing multiple things. Someone's height, their GPA, and their gender. So now when we create this, what will change about this specifically here is we're going to go down from the 20 variables down to the 3. So select is an additional argument right here, which selects certain columns. So now you can see right here, we only have the 3 columns, and that's what the select argument does. There's a lot more arguments, like subsetting has a lot more ways of going through it. But Trace, walking through this right here, does this make a lot more sense? Do you see what's kind of going on here with each of the arguments, where we have here 2 conditions by the sub-indent, because you could always set more conditions. You could say somebody, I didn't do the and. You could say, and somebody's height is less than 72 inches, and that'll eliminate a few. Yeah, so we're still within, we're saying, and this condition is true. So these are only people who have a 3.0 GPA, who are right and left-handed, who are either right or left-handed, because their handedness is contained within right or left. It means they must have one of those 2 to return a true, and somebody has a height less than 72. And so that should do it right there. A lot of good practice here with logicals, seeing that this is all the conditions right here, especially by the sub-indent. That's why hitting spacebar or enter can really help. And then the last argument right here is choosing the columns we return or the variables we return. Let's take a look. We have Blake's question, and then let's take a look at William's question. Let's do this. A little bit of music. Always good, my sad chill music. This is my chill music. This is my theme song. Let's do this. Number 2. Bringing up the... Myra's acting weird. Gonna eat some vegetable rice for lunch. Good stuff right there. Healthy. I just tell myself it's healthy to remind myself. Number 2. Here we go. So Blake said, are you able to help me interpret the code on number 2 of the homework? Yep. Let's take a look. Okay. I'm just clicking random buttons. Do I have everything working? 2 seconds. Good. It's working. Let's do it. So when it comes to number 2, what is this doing? That says 1 right there. It says 2 now. What is this doing right here on line 59 of the code? What is that doing on line 59? Like, be very specific right here. Like, if I said, explain that to someone, storing data, pretty much, Blake, great job right there. Let's throw some 20 points. William was asking, where are those points at? Blake just got us some points. It is, and it's storing, you are correct, that is data. I would say it's a vector. Like, you could get really specific. You'd be like, storing a numeric vector with 4 elements into the object X. Like, it's creating something X that has those values in it. Like, that's a little less descript, which we can go very descript, or just X is created with 7, 10, 2, 3 inside of it. And you can see this if you take a look. You run the code and you see over there in the global environment, X down here at the bottom, and it has 7, 10, 2, 3. Now, we want to run a repetitive task right here. We want to run save into position 4, 5 times X position 2 minus 3. So this is literally going to go here to position 4 of X where 3 is at, and overwrite this with 5 times 10, so that's 50, minus 3. So 47. Can I do math in my head? The answer is, looks like I can. So if you notice what I did right here, I went to position 2, what was in position 2, which is 10, and I times it by 5, so 5 times 10 is 50, I minus 3 off of it, and this gives 47. Now, when we get down to this line of code, it stores into position 5, 6 times position 3, which is 2, which is 18, minus 3, so it's going to store 15. It's just doing the mathematics. Remember, oh, I can't do math. Times 2. Okay, that's 6 times 2 is 12, minus 3 is 9. So this is 2 right here. If you see, that's position 3, which is 2. That's just going and resourcing that value, and we are getting here stored into position 5, the number 9, and we can see this. Now, this is a repetitive task that repeats and repeats and repeats and goes down here to the 10th element. With it going to the 10th element, we could do this task by just grabbing a skeleton. So first thing I ask you to do is identify the vector of numbers it goes through. When you type 4 and you hit enter, you get the following. What vector of numbers does this look to go through right here, Blake? What vector of numbers does, like, it looks to go starting at this, going all the way to this? Fletcher, good to see you here. Just popping by and recommended. I was astonished to see the lack of hair. Oh, I know. I'm so sorry, Fletcher. It's gone. I'm trying to get healthy. Getting healthy means cutting your hair. No, I'm just kidding. No, I'm trying to, I don't know. I started dieting and I was like, you know what? I'm going to cut the hair and get healthy. And I've almost been doing it for a month now, I think. This will be week 4 on Sunday. It's like, got it. Well, that's not what, so that's the vector X, correct. But as we go through here, 4 goes up to what? So X is the vector. X is a vector. Correct, X is a vector. But in the for loop, what is the numbers that the for loop will go through as the for loop runs? It'll start at 4, go to 5. The for loop, one set of, great job right there. Good to see you here. Excellent work. Doing some practice in R. Feel free to ask or answer some questions. Excellent work right there. We're throwing 20 points. I love it when people swing by the channel. Maybe they're practicing coding. Great to have you here. It is going through the vector 4 through 10, and there's multiple ways of doing this right here. So it's going to go through the vector of 4 through 10. And now here's a key thing. What can the placeholder be? When we make a for loop, we try to make something usually intuitive, but what can the placeholder be? Which is the variable right here. This is specifically the variable, and that's what R calls it right here as a variable. But what can it be? And this is something we should always know, that the placeholder variable thing that will change and be our placeholder, it can be anything. It just, you call it whatever you call it, Brian, if you want. Doesn't matter what you call it. That's just a placeholder thing right there. That's just going to, whatever you want to call it, you call it that. You call it stat201. It's good about that. Now, you got to watch out. There are reserved things inside of R. You can't call it true because that's reserved. So it's anything minus. And actually, great answer right there. We usually call it I. That's usually a good thing to call it because it's just super quick and simple to call. So if you use I right here, one of the quickest things to call, especially for positions like the ith element, that's a little bit more intuitive right there. So I would usually suggest something like I because that's just quick. You just do I, super easy to write. And I suggest lowercase I because, well, uppercase I looks all right too. Now, we need to identify the skeleton. The skeleton is the inner part of the for loop. The skeleton is what runs every time the for loop runs because the for loop's going to start up here at the top. It's going to store 4 into I. Like if I'm writing out what this for loop is doing, I'll show you here in a second. I'm going to take this right here. Let's write a version of the for loop without for looping it, like the hard way. We go right here, we store 4 into I, and then it's going to need to replace what is in here with I. Like we're going to do that for this time being. What should 4 become? This is the easy one. What should 4 become? 4 needs to be what now? Because 4 is going to dynamically change when we run the loop. The first time the loop runs, 4 is I, so what should 4 become? Don't worry, this is not a trick question. The first time the loop runs, I has been assigned the value of 4. And so 4 is something that dynamically changes. 5 will dynamically change. 2 will dynamically change. 3 stays static. And we'll remember that at the end right here. So what do you think this 4 will become right here? What will that 4 become? Because it needs to go through a vector of values. It'll go from 4 to 10. So the first time the loop runs, 4 will be called what? Because right now I is 4, so what will 4 be? It's not meant to be a trick question, I promise. What do you think? Let's throw some points. Getting tons of interaction right here. If you're a visitor, we welcome you. Thank you for being here, especially if you're practicing coding, just getting a little for loop practice. It's not a trick question. I swear it's not a trick question. Right now, 4 is I. So what should 4 be? Not a trick question. Promise you, not trying to trick you. Like you trying to trick me right here. You're trying to get me to say I know it. You're trying to do that. I'm not going to get tricked by you. What should 4 be? I'm kidding. It's I. I had to do that. I'm kidding. It's I. It's definitely I. Now, 5 also dynamically changes. Oops, didn't do that yesterday. Yes, exactly. And exactly as you're pointing out right there, and if you can tell me phonetically how to pronounce your name, that's awesome. Thank you so much for swinging by and helping out right here. Because the next time it runs, it will be 5, and the loop's going to update this by updating what I is through the positions of the vector 4 through 10. You got it, Blake. This is the practice, man. First time you learn for loops. It's important to all forms of coding. You got C++ using for loops. You got Python using for loops. For loops is something, if you know the structure within one coding language, you can do it in other coding languages. So if you tell me, I think it might be Russian right there. If you tell me how to pronounce the name, I will. I just don't want to. I want to say it correctly. But if whatever you're programming in, if you do some for loops, awesome practice right here. Now 5 is not going to be 5. Remember 5. We want to somehow write 5 in terms of I. So I is currently 4. So how can you write 5 in terms of 4? Such that it would dynamically change. Because if you notice what this is going to do, it's going to go 5, 6, 7, 8, 9, 10, 11. So if you notice its relationship to 4, you can kind of say, or like 4 and then this, 5 and then this, 6 and then this, because I is going to go through the values of 4 through 10. And so this should probably be I something. This should be I what? Just think about if this is I, you're Blake, man, Blake. Some 20 points, Blake, right there. Yep, Blake, you're getting it. Blake, excellent work. You're seeing it. This is going to be... now, I'm not going to give you any hints on this one. You ready? You got this. They're throwing some integer vector at it right there. Great work. So, and it is integers. It is integers. And I wonder, because that's a little bit... What language do you code in? Do you code in R? right there, calling the integer right there. Right here, we have 2, and just look at its relationship. Not giving any hints. You got this, Blake. Everyone's free to answer 2. We're all here to help and practice. So what do you think 2 will become? And then we'll look at 3 here in a second. What do you think 2 will become? Now just look at its relationship to be like, okay, wait. If we just called this I, and this is over here, and this is I, and this is over here, and that is I, and this is over here. Because I goes through 4 through 10. So will it, well, so what do you think 2 will become? Like when we run this right here, we said that this would be I, and this would be I plus 1. And then, so what do you think that 2 will become right there? Like, look at its relationship to this and what relationship it always has. Like, look at this. Look at me. Now look at you. Look at me. Now look at you. What do you think the relationship? Look at me. Now look at you. What is the relationship right here between these 2 where this would be I? Because this will be 4, and then this will be 2, this will be 5, this will be 3, this will be 6, this will be 4, this will be 7, this will be 5. So if this is I, this is always what? Boom, right there. Great job. Yep. So we see it right there. Excellent work. Thank you so much. It's going to be I minus 2. And you can just plug back in here 4, and you can see how it works because currently I is 4. So you can see it would be, great job, Blake, and everyone right there. Is this making sense how it currently has these values? Now you might say, well, then shouldn't we think? Obviously 3 needs to be I minus 1 because, you know, right now this will solve for 3. Or it won't, because I must be 5 right now. I apparently had I stored as 5. Now it solves as 3. I just didn't run this line of code, and I'd used I somewhere else probably. So with I currently stored as 4, but why is this wrong? Do you notice how 3 does not dynamically change? 3 is static. So we don't need to cause something to be resourced as I right here. 3 is just going to be 3 the whole time. Like that's why don't change it. This is wrong. So not that. This is wrong. This is right. So what have we just written right here? We have written our skeleton. Our skeleton is the code that repeats. Because I could run this for loop by going like do, and then going right here and going badow, and just doing this right here. Doing the following is running my for loop, and this is what my for loop is going to do for me. You might say, well, you're just doing it yourself, Brian. Isn't that just easy enough? Well, no one's got time to do that. Like, I don't know how I even did that. I just did the impossible. Here we go right here. Tail. So here we go running the for loop right here, and it's doing the whole thing for us and creating the vector. Yes, you could do this 10 times. Yes, you could do it 100 times, but could you do it 1,000 times? Can you do this? Oh, I broke it. For I in, what did I do? Let me go grab my vector x. I must have done something crazy right here. Ooh, what have we done, everybody? Ooh, I changed the code around, I feel like. What did I do? I did this yesterday perfectly. Dun, dun, dun. I'm throwing errors at you to see if you can find the error. It says oh, I know it. I did everything correctly. Everything here is correct. There's not an error. It's just R is getting mad. Really? It gets that big? Oh, because the vector x needs to be recreated. Yeah, the vector just gets that big that quick. Nothing was wrong. Everything was right. It's just that the vector gets that big that quick. Also, if you create a large vector and then you run a for loop that overwrites certain values in that vector, it will still keep the length of the vector. So when I created my vector right here of like 1,000 elements, then even if I create like a vector with 8 elements, I'm just overwriting the current vector and it's still showing me the end of the 1,000 element vector, which it must have created a 1,000 element vector. I have to restart my x vector to get the vector. It's just that after a certain point, apparently numbers get so large that R just starts calling it infinity. Does that make sense right here? Be very careful. I kind of put the answer on the screen. Just make sure you only go to the 10th element. I would accept it if you went to the 100th element because I think I put a typo in here where it said 100th element. But I would go to the 10th element right here. But is this making sense right here, Blake? How's that looking? We'll hop back here to space. Let's do this. Put on a little music. Hop back to space. I think who had another question? Did Trace have one? If you have a question, let me know. Oh, there, William has one. 3A, very little suggestions associated. The medians are relatively equal and the IQ are very similar. The whisker shows them in the max areas. That's looking pretty good, William. I might take a look at that. You're welcome, Blake. Excellent work. And I did. Yeah, let's go take a look at William's question right here. Everyone, thank you so much. Awesome office hours today. I'm going to go eat some vegetable rice. I'm excited. I just want to go eat a Five Guys burger. Five Guys burgers are just top tier. You're welcome. Are you visiting? Do you code in computer science? What do you do? We are always happy to have people visiting, asking questions. We've had people, now we've had someone from, I think, across the ocean visit us. Swing by anytime. We appreciate you. We're here to just learn how to code, spread some positivity. And Brian's trying to find the... I must have closed it. When you can't find something, here it is. I had the chi-squared distribution open. Below, awesome. Let's take a look. Okay. We got William's question here on... Yeah, I see William's question right there. Cool, cool. Let's go take a look at this right here and hop into it. Okay. So William's question is about the associations right here. Medical background, I'm trying to learn R for medical data analysis. Well, you can always email me. I'll drop my email in the chat right here. Feel free to say hey, and we're honored to have you here. Learning some R, doing some practice. That's my email right there. And if you want to just have any general questions, University of Tennessee, Knoxville, Brian Stevens, feel free to ask and be like, hi, I was in the chat and I'm just learning this or that. And yep. You're welcome. Yeah. And if you ever want to request a video, be like, hey, it'd be cool if you could make this video. I might be able to make it. I'm glad you found our channel and I'm glad you find it helpful. I've got playlists on getting started in the basics in R. I'm going to drop that in the chat really quick right here. But I would suggest my getting started in R basics. It's like 1 minute videos. And so I would hope those 1 minute videos are helpful. Where's that getting started in R playlist? It's got 18 videos. Slightly longer hair than me, and so sequences inside of R. You can tell me if they're good or bad, and you'll be like, William probably thinks the videos are trash. So William's always joking about that. Okay, so here we go with this question right here. We got some box plots, which are going to show us the quantitative distribution of demand right here, and we've got the day right here, which is Friday, Monday, Saturday, Sunday, Thursday, Tuesday, Wednesday. I mean, yeah, if you didn't know, that's how the days are ordered. Trash, Williams. 20 points, William, right there. And one of our first visitors was Calzone Tyrone from New York. So Calzone Tyrone appears every once in a while. We're always glad to see him and glad to see you here too. Awesome work. What about this plot suggests there may be an association between the day and demand? So there's a lot of similarities in these, but if you zoom in, you can see the scale. You zoom in super crazy on it. You can see the scale on here is in thousands of bikes being commissioned out. These are bike kiosks right here. And there is some differences. Like, this difference might be small, but imagine this is your salary, where person over here, this group or whatever, like for a certain job, has a median salary of maybe about 5,000 something. And this group right here has a median salary of 4,600. Is that making sense right there, William? William says, oh, shoot. But there's small differences between the medians. That's kind of key as we're looking at medians. There's also some differences in the IQRs. I think you mentioned that. You're right. What's something am I right about? I don't know what I'm right about. There's some differences between the medians right here. There's some differences between the IQRs. There's differences between ranges. Like Saturday has a very large range, has a much, like there's more variation in Saturday and it has the highest median. So, you know, the differences might be small, but there are some differences. We can analyze to see how big these differences are and if they're unlikely by random chance with a p-value here in a moment. But you definitely see like smaller IQR here, larger IQR over here. So there's more variation in some days. You see here small differences between the medians. I'm not saying that's the biggest difference between the median of Saturday and Sunday, but it's something. They're not right perfectly lined up. So there are discrepancies. And when we say discrepancies, we're talking about these differences we see between the groups, discrepancies in the medians, discrepancies in the IQRs. We don't really run analysis on IQRs, at least in this class, but IQR would be a measure of spread of data. the interquartile range, the range in the middle 50%, and this one has a more compact range of middle 50%, where this one has a wider range of middle 50% of data. So I would say there could be, I don't know, there's just differences among the days with the medians and the highest. I'd mention maybe the highest, like I'd say like the day with the highest demand for median was seen to be Saturday, which also has a large amount of variation seen by the range and the IQR, where we see some days have less variation in them, like Thursday, for example, and some days, while having large variation, Sunday, have lower medians than other days, including Wednesday. Just talking through, and there's differences between the days. So are these differences statistically significant? I don't know. This is something we did not get to today. We'll get to it tomorrow, so let's briefly discuss it. The F statistic has been calculated for this data, which turns out to be 4.7, which is what is the practical interpretation of this number. Now, an F ratio, in this instance, the F ratio is the observed variation between the groups versus what we would expect by random chance. So if you think about this, when the F ratio is 4.7, what does this mean to you about the variation you observe versus what you would have expected via random chance? So just kind of use this right here, like the observed variation we saw between the groups was what versus what we would have expected by random chance. It's a ratio. Like it's saying to you, let's go out and get a steak. And I'm like, let's go out and get a steak. And you're like, go get a steak, probably about $10. And then you go get the steak and it's $47. So there's an F ratio of 4.7. So it is greater. The observed variation, what we observed was greater than what we expected via random chance. But think about this. Like specifically, if you would say to me, Brian, I expected to pay $10 for that steak. The steak turned out to be $47, what I observed. So when you think about what you expect via random chance, which not quite the way you buy a steak, like by random chance, and then what you observe is what you actually see when you run the data, like your specific results, your data has the observed results. And then that gets you the F ratio right here. So we could just plug back in F here because we're talking in the general sense up top and then a kind of wacky example, which I'm known for. So the F ratio right here is telling us kind of a ratio. The model versus the residual, signal versus noise. Exactly. Man, top tier answer right there. Yep. And then with business analytics, we go to like the application sense of it, to that the model is doing a better job than the residuals, like what is left over, the variation due to random chance. And so some ANOVA tables right there. Like we go classics on this, amazing. We are proud to have you here. Here we'll just make a quick ANOVA. And if you look at how the ANOVA actually calculates it with the F statistic, let's go here to LM. We'll just go height tilde weight. I think I've got these variables in as vectors right now. And then we'll store this as model M. And this is just how to make a very quick ANOVA right here. And you can see right here, the ANOVA gives you the F ratio, which our model is doing. It's a comparison, as you just said, to the signal versus the noise. And to get into the very specifics, like sometimes in business analytics, this is why you're maybe hearing me do more of a practical interpretation, like for a boss, because I could say like the mean sums of squared error that our model explains is 394.2 times more than the residual leftover, like the noise, like you're saying right here, the residuals. And these are excellent words, because when we talk about residuals, we're talking about the noise, the unexplained, kind of the things that are bothersome, we can't understand. It's leftover variation. And on average, because we're doing the mean sums of squares right here, that's how we're obtaining this value. It's the average of this. To get the mean sums of squared, we have the remaining residuals, and there's the mean right there. You don't get all the decimals. There's only one X variable in this model, so we're seeing right here the sums of squares and then divide by 1. It's the same thing. Now the F value is a ratio, which is what we observe being explained versus kind of the noise remaining in the model. And we sometimes say what we would have expected by random chance, which is the remaining variation in the noise. And so when we take this ratio down here, we get the following, and that's the more mathy way of doing it. And once again, there's more decimals being carried around in the background that we're not seeing. If I do this right here, I might get a more exact answer. I think it's because of so that's a lot closer to what it has up there. It's just that there were decimals in the background we didn't see to get the F ratio, because this 12.6 doesn't have its remaining digits behind it, and I used that. And then we get the p-value right here. Now, what's very interesting, and so these are some small subtle differences, is we can do this same sort of result right here, with permutations. And this is where our class is a little bit different than classical statistics because we're using simulations right here to simulate the F distribution, and I'll show that. So this is the crossover between what you're doing and classical statistics. This is a simulated F distribution down on the bottom. Arrow to play. Darn you. We do have some problems with some outliers and straight enough. So we are simulating. Oh, that's the normal curve. Wait, my brain broke. Let's go down here and simulate an F distribution. To simulate the F, we need, okay, here we go. Simulated F distribution down here on the bottom. And here is a simulated F distribution down here. You can't see it. My examples are failing today. Here's a simulated F distribution. Can we actually see it? It's going to be so zoomed out because our discrepancy. Let's make a discrepancy that's a lot smaller than that. GPA differences. And now we're getting to smaller discrepancies. There we go. There's a good classic F ratio right there, or an F distribution. And you can see these are simulated due to permutations. And that's something we do in our class right here is the permutation procedure, where I was talking about, I basically walk in with your grades and just throw the papers up in the air and just say, grab the grade closest to you, creating results that are due to random chance. And this kind of connects today's lecture into talking about, we have our observed data, then we have what would happen by random chance, and we take a look at our result and what the probability is, p-value of our result or result more extreme occurring by random chance, given that the null hypothesis is true. What you would expect is small discrepancies. These are the likely discrepancies by random chance. And then the very large discrepancies, which are more extreme than our observed result, are going to tell us the p-value. You can tell the p-value here is 0, much like this example. And maybe I'll do one that actually doesn't have such crazy discrepancy. Let's look at the differences between how far people move to school. And the answer to this, is it a big discrepancy? I would hope it's not. We'll find out. Got 1,000. Yeah. These differences right here are likely due to random chance, and you see a simulated F distribution down here on the bottom, especially when we talk about the averages, which is the mean. So here we're comparing the differences, and there's a huge problem here with the non-normality of this data. So in truth, we should be using the medians, but you can see the medians, there's no difference. And then we're simulating down here permutations of random chance, and the discrepancies we would get are much larger. So the p-value here is going to be basically 1.98 or something ridiculous. Let's go look at that p-value for the result. And the p-value for this one is 0.8. It's actually bigger than I thought. I guess there's a lot of very small ones. And then we even get a confidence interval for the p-value, which is super cool about the way we do it. So we're estimating the p-value. Yeah. And if you want this package, if you're using R, every code I'm doing right here, keep asking questions. This is the Reg class package. So this is created by Dr. Petrie at the University of Tennessee. Reg class, just check it out, and you can see the functions inside of Reg class. I'm trying to update the code to use, if you know ggplot, Shiny, all that stuff. Side project I haven't done all of, but if you go to the Reg class package, a lot of great functions for doing regression, hence regression class. And so yeah, right here, and it's on the CRAN server. If you're worried about what you're downloading, it's on the CRAN server, so that's official R stuff. So you don't have to change repositories. But it's got correlation demos, it's got correlation matrix. Probably one of the best codes, and we'll hop over to a new question after this. One of the best possible codes. You're welcome. Check this out. This code we'll get to see in our class on Thursday. We'll be talking about this code on Thursday. So this code is called core. What am I doing? All correlations. That's what I'm doing. All correlations. So what all correlations does is it takes a data frame, and guess what it gives you for a data frame? Instead of a correlation matrix, what do you think the code all correlations does? You might say this is a mess. I can't look at this. And then we'll talk about the arguments here in a second. This will be our class on Thursday. Thursday, correct? Yeah. All correlations gives you all the correlations. Well, watch this. You might say, Brian, I'm only interested in GPA. So let's go here to interest equals GPA. I had a space right there. So with interest equals GPA, instead of getting every single correlation, now we just have the correlations for only GPA. So by running all correlations, and then with the argument interest equals GPA, it did only the ones where GPA, and sometimes it's in the first or second variable, but we see right here just the correlations of GPA. But let's go a little bit further, and let's go here to sorted. I put the comma in the wrong spot. Let's go here to sorted, and my favorite way of doing it is magnitude. And now with sorted equals magnitude, we have here the strongest correlation. Yeah, this is one of my favorite things Dr. Petrie created. It just does all the correlations. You can choose the variable of interest you want for a data frame, and then you can sort it by strength. We'll do positive to negative, magnitude, and I think there's one more. You can look at the documentation for it, but by doing question mark all correlation. But this is probably one of the most helpful little functions that just runs all the correlations on a data frame. So the first argument right here is the data frame you're putting in. This will be a variable name, the variable year of interest, and this will be the method for sorting. So that's kind of the quick rundown on it. First argument is what data frame am I looking for all the correlations on? Second argument is variable of interest. And then third argument, you don't have to use all of them. You could, like the first time I did it, I just ran all the correlations. So you could find the strongest correlations in this data set with the following. Here's all the correlations in the data set, just right here. And you could always do this, write.csv. Maybe your boss wants a CSV file. And there we go. And now we've got it saved as a CSV to send out. So this data set right here would be openable in Excel. And we just saved all the correlations with the following code. Just we wrote it as a CSV. But this is the kind of practice we hope to get right here and kind of building these skill sets to say, maybe I just want to send somebody all the correlations so they can look through. I mean, it's shocking. Someone's height or their weight is correlated with their desired weight. Someone's height's correlated with their weight. Shocking things you would never expect. Then we get to some interesting stuff like someone's desired weight is highly correlated with how funny they think they are. Someone's athleticism is correlated with how funny they think they are. Someone's intelligence, how intelligent they perceive they are, is how correlated with how funny they think they are. And these are very strong correlations, very statistically significant and moderately strong correlations. Moderate range around 0.5. Well, I think let's hop back here to space, see if there's additional questions. Well, I think that's got it. Great job, William. And if you tell me how to pronounce your name, I'll pronounce it correctly. Because I think it's Russian, right? If you put phonetic pronunciation in the chat, and we're always honored to have you swing by. Blake, Trace, great to see you here. I think we also had a lot of other people. Great job, Ben and Brandon and Adam. Adam swung by to say hey. Trace again. I think that's got it. Bulgarian? It's Bulgarian? Awesome. Bulgarian. And if you put a phonetic pronunciation, I'll do my best to do it correctly. Kostadin. Is it Kostadin? Kostan right there. It's interesting, like seeing like the letters I'm not used to. I'm like my brain's like, how do I say that? And so, but then you learn how to say it over time, and you get practice, and that's how it works. We learn new things, and I appreciate that. Kostadin. So I'm from New York, so sometimes my accent, like you'll hear me say water, daughter, like all those things, but then I usually have a neutral accent sometimes. But you'll get to hear a New York accent every once in a while. I think that's got it. If you like some Star Wars, we're going to end with Star Wars today. All's welcome to swing by. I handle all the different questions. If we get to some free time like we did today, I'm more than happy to talk about different things. Feel free to email me, bstevens@utk.edu. We're going to hop over here, and we're going to see a little Star Wars in class. But for now, everyone, Puppet Shark, you ready to say bye? Yeah. Let's do this. Bye for now, everyone. Bye. Jason, can we keep going? Jason, we just need to film for another 4 or 5 hours. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.